Thank you, John. I got a master's degree in operations research, and I think I spent 12 months at Case Institute of Technology in 1962-3. I learned a lot. I picked up a lot of tools and ways of thinking that gave me a huge advantage in economics. These tools led to a revolution in aggregate economics. When I was an undergraduate taking economics in 1958, the price theory part is pretty much the same as it is today. Some people call that micro. Not anymore, with all the developments in game theory and strategic behavior, et cetera. The other part was called macroeconomics. That has not stood the test of time. And I will explain why. As I said, macroeconomics has experienced a revolution. Let me give you a little history. There was no field called macroeconomics prior to the Great Depression of the 1930s. That was a pretty bad depression. It lasted a decade. During that decade, employment and output were depressed 20%. Output relative to trend, employment per working age person. What do the economists have to say about that? Not much. They didn't have any tools to construct models to think about it. You can't think without language. So what did they do? They said we'd have to do something, so this is what they did. They said, let's empirically determine the dynamic system governing the evolution of the aggregate variables, the macroeconometric models. As you all know, the basic structure was the state of the system, and the values of policy variables determine current outcomes and the distribution of next period state variable. The view was that in time, the economic foundations for the empirically determined system would be developed, and then macroeconomics would become part of economics, as opposed to being a separate discipline, separate but related. By the way, things like this happened in physics. Galileo ran his little experiments, and it was somewhat later when Newton came up with the general Newtonian mechanics. By the way, people like this framework, this macroeconomics. Economists like to feel important. And we could help. You know, we're social animals. We want to help, and we had something good. Basically, in that framework, you could use the models to predict what will happen conditional on the current state and the current policy action. You can use control theory to find the optimal policy for a given social welfare function. In my dissertation, I used this framework to find optimal policies. The key extension was there was uncertainty in the coefficients, so it became a Bayesian sequential decision problem. The prior and the parameters were an element of the state variable. Just thinking this way and using state in the has been such a change. Back in this ancient history, the 60s, people would just shake their head and wonder what you're talking about. Not operations researchers. I had been exposed to those. One particularly valuable course in this recursive methods and tricks of the trade was the queuing theory course. I think the book was Sadi or somebody. Professor Maurice Sassini was a I found to be a very outstanding professor. There were people. That's one of the key things, people in the queuing models, not just a bunch of equations, like in the macroeconometric models. Now, back then, McQueen and Miller surge problem. I think that appeared in operations research about 1957. About 7 or 8 years for a non-sequential search. It's a major, George Stigler, that was one of the papers that was cited in his award, though his work on the capture hypothesis was major. The SS inventory problem, people like Scarf, that's a tricky one, and you need the dynamic equilibrium tools. In the 60s, economists used the variational methods. They'd have one state variable and the co-state and draw their little phase diagrams. The people in the technologically backward areas of the country, Cambridge, would use that methodology for another 15 years before shifting to the better language. Yeah, they resisted the use of general equilibrium language where the givens, the data, are people's ability and willingness to substitute, and the nature of the policy arrangements set up, not supply and demand functions. We've gone beyond supply and demand. They're not things you go out and measure in the general equilibrium framework. Tom Sargent elegantly, last year's Nobel Prize winner, stated that in the late 1970s. Really, the methodological, I wasn't really an economist back there in 1969 when Lucas and I wrote this paper. I came in with the expertise in the recursive methods in that branch of mathematics. By the way, he's a major league mathematician, and he learned it like that. And you ought to read that book if you ever have to. Recursive methods for economic dynamics. Every student has that on, and and even the mathematicians say it's a well-written book. Stokey and Lucas are the authors. Well, we use dynamic programming tools to solve the investment under uncertainty. It was that industry equilibrium, and I emphasize equilibrium. In an industry, there was a bunch of firms. We had a special structure on the technology that permitted aggregation, and we could summarize the state of the industry by the total capacity. In order to analyze it, we had to go to general equilibrium modeling. We had to put in a stand-in or fictitious household with the right utility functions that gave rise to the assumed industry demand functions. By the way, I want to emphasize equilibrium just means consistent maximizing behavior. We borrowed a term from the natural sciences and used it incorrectly. Which is more a system at rest, or rest point is what economists, or balanced growth is what economists call this. What really destroyed the old Keynesian macroeconometric models? They came to prominence in the 50s. Everybody said there's going to be a Great Depression in the 50s, a repeat of the 30s. The Klein-Goldberger model was one of the first serious, small but serious macroeconometric model. That was an honest research program. Said there would not be. The people at Sears Roebuck listened to them, and Sears became the dominant retailer for many years. Montgomery Ward listened to what everybody knew was going to happen, the Depression, and they sort of faded from being a competitor with Sears. One of the model's prediction is higher inflation, lower unemployment rate. This is the case because one of the equations in the model was the Phillips curve, which had this relation. And probably the most important paper ever written in economics, Expectations in the Neutrality of Money, developed a model that displayed the empirical Phillips curve. But there was no exploitable trade-off. If attempted, this empirical relation would not hold. If you didn't exploit it, then it would, or try to exploit it. In the 1970s, attempts were made to exploit this trade-off. It failed precisely as forecasted by the dynamic economic theory, just as Lucas predicted. The inflation rate was increased from 4% to 9%. This was accomplished by increasing the growth rate of the money supply. Unemployment did not drop from 4% to 2% as predicted by macroeconomic theory. Rather, unemployment increased to 9%. So we had a 9 and 9. In 1969, it was 4 and 4. So what was the state of the economics? We knew the old approach had failed. But the issue is what to do, given the spectacular failure, predicted failure. There was a lot of interesting conjectures made by a number of very talented economists. But there was no quantitative, systematic discipline. You've got to have discipline in science, or it's not science. Then I was fortunate to meet Finn Kidlin when I joined the Carnegie Mellon faculty in the fall of 1971. He had training in management science, and like me, was proficient in recursive methods and computer programming. So we had people to work with each other. I made lots of mistakes. He never made any. But I could go a lot faster than sprinting, but he could work for the 20 hours. At that time, his advisor had returned to Norway, and he was writing his dissertation on his own. Stentori. I ended up being the chair of his committee. But more important, I ended up being his collaborator. Kidlin and I knew from Lucas that the equilibrium dynamic system could be determined if the policy rule that will be followed now in the future is specified, and only if. We searched for the optimal policy rule given a social objective function. That seemed like the logical thing to do. And we were using recursive methods. We found that an optimal rule did not exist. This is games. It's not a game against nature where you can use control theory. Well, policymakers often pay no attention to this scientific fact, and indeed they even pass legislation that says the Fed has to provide, the Humphrey Hawkins bill of, I think, 1977, said that we had to sort of say what would happen if policy is A, B, and C. We at the Fed, well, I was a consultant beginning in '81 to the Minneapolis Federal Reserve Bank. And these are questions that this language cannot answer. They're not well-posed economics in the and this doing what's best at the current situation is dangerous. It leads to bad outcomes. That's what Finn and I found. What the key contribution that Kidlin and I had was they mentioned two things: the time and consistency problem, which is related to too big to fail, and et cetera, and an independent Fed. But more important, I think, was the methodological contribution, a set of tools to how to construct models that interacted with the reported Statistics. What we did was we introduced an aggregate household into the growth model. The growth model was not part of what they then called macroeconomics. It was part of microeconomics, they then called. On that, they just treated people like, in the original growth model, they just treated, of solo, they just treated people mechanically. They saved a certain fraction of their income, and they supplied their labor inelastic, a fixed amount. They didn't respond to incentives. We were influenced by the labor economist and introduced an aggregate household. And so I call it the neoclassical. Neoclassical means you have both a willingness to substitute as well as the technology side of what you can do, which is the classical economics. We restricted the parameters of that growth model to be consistent with the growth facts. These were documented facts that had been developed over the previous, I guess, 50 years, beginning about 1930. We found that the growth model displayed the business cycle facts. This was not, everybody said it couldn't. They were using partial equilibrium reasoning. If you reason on the basis of what an individual family or unit does, you're going to get the wrong, typically get the wrong conclusion for the aggregates. The factors had to be like technology, which you increase through your work, more output per unit input, productivity, I should say. Taxes also matter. Terms of trade also matter. We call these real things. These are subject to persistent changes that affects we call it balanced growth facts. Certain ratios stay constant, though all the real variables grow, except for the amount of time that people work, that stays constant. And the interest rate stays constant. One thing it did, it was only true if people's willingness to intertemporally substitute leisure, work more now and less tomorrow, or the reverse, was high. And there was this aggregate willingness being high bothered us, Finn and I. Why? Because it was inconsistent with what the labor economists were finding for prime-age males, looking at using panel data, how much they work and what they are paid per hour over a period of time, a bunch of people. They didn't work a lot more when the compensation per hour was higher. There's a lot of reasons for that. If you move up in the organization and become a supervisor with a higher pay, do you work more than the people you're supervising? No, you continue to work the same amount. There's team production or club production which has been, theory's been extended. Richard Rogerson, who did so much to build the ASU economics department, came up with the answer to these apparently conflicting observations, which is, if the principal margin of adjustment is the fraction of people working in a given week and not the length of the work week, a prediction of aggregation theory is that the aggregate household will be much more willing to substitute leisure than the individual being aggregated. So if you look at what an individual does, you do not get a good picture. There has to be some non-convexity somewhere. Empirically, the principal margin of adjustment is the fraction of people working in a given week. There's a couple margins. In France, they work 40 weeks a year. In the US, it's 46. There's also the fraction of the lifetime worked. Americans work a bigger fraction of their life. The French start working later and retire earlier. Rogerson and his student Johanna Wallenius, ASU PhD, currently at the Stockholm School of Economics, and here today, has shown this in all kinds of situations, and it's just overwhelming evidence in support of this. One of the biggest things was, if you look across countries, one of the great things that happened in economics is we got much better data sets that are cheap to access on the internet. That technology made a big, big difference. The US is currently 40% more prosperous than Western European countries. This is GDP per hour, and about 20% better off because they have more non-market time, which is valuable. The reason is that the US market hours per working age person is 40% higher. This was not the case 40 years ago when Europeans worked the same amount as Americans do today. So the Europeans changed, not the Americans, or Canadians, or Australians, or the Chileans, other people in advanced industrial countries. One of the things, there are large differences in effective marginal tax rates across countries, and over time within some countries. Using the intertemporal willingness to substitute leisure and an equilibrium relation, that intertemporal substitution leisure that is needed for the business cycle observations, using that number, it predicted the actual cross-country hours per working age person quite accurately. It was a remarkable conformity with the predictions of the theory. There's one country that was way off, Turkey. I met somebody from Turkey today. It should be on that 45, predicted and actual on the 45-degree line. They were way off. I asked Ayşe Horlu, who's a collaborator and a former student, well, what's going on? And about a year later, she came back with the answer. Turkey did not have labor statistics. So what'd they do? The people in these international data sets, they used the Greek data. And everybody knows about the Greeks. They're unique people. Now, I said over time, when the Western Europe in the early 1970s had the same marginal tax rate as the US did then and has today, they worked the same number of hours as Americans do today and then. Actually, slightly more. But they were growing faster. Using Kydland and my methodology, a lot of problems have been solved. There was the puzzling US hour booms of the 1990s. You know, that was looked like a weird boom. It didn't work like the theory said before. People were working too much. Productivity was, output GDP per hour was down. Corporate profits were down. Normally in booms, corporate profits up. GDP up. Normally in a boom, 1/3 productivity, 2/3 hours worked. Well, it's 125% hours worked and minus 25% productivity. This was a puzzle. One answer is that there was a contagious case of workaholism. This is in the language of spirit of Keynes's animal spirits. But it was not Greenspan, though he would like to take credit for it. Or Clinton. Both of them did a reasonably good job in their respective roles. Clinton letting the boom happen. Greenspan keeping price level reasonably stable. It all came down to a measurement problem. By the way, the same model accounts for the current depression, but it's people got contagious cases of laziness, is what some of the Keynesians say. I assure you that's not the case. These students want jobs, and they'll work hard. People are not entering into this employment contract, which involves a big investment on both sides. But a more recent thing is McGrattan's the role of expectations of future policies. If you don't know what's going to happen, and if you just have put probabilities of these regimes and behave optimally, a lot of times it's best to wait to find out what's going to happen and before taking action. Well, this is not quite a linear talk as it should be, but just to refresh your memory, the key development facts. Prior to 1800, living standards varied little across countries and over time. Indonesia and its colony, Dutch or Netherlands and its colony Indonesia had the same living standards in 1800. I assure you that was not the case in 1970 or 80 or even today. There was this picture shows, I could go back to 10,000 BC when there was a significant shift from hunter-gatherers to the farmers, and these having in small villages and some specialization. There's about a 32% jump in. It all started around 1800 in Western Europe, particularly England, not Scotland. That was a little later. Scotland had the good educational system and the great economists, Adam Smith and others. I think they shut down Oxford and Cambridge in this period, and all these creative people went into business and figured out better ways to produce. A lot of their methods were empirically based. Now, as the West started growing in its offshoots, like the U.S., Australia, Canada, started growing in Western Europe, started growing at this steady, sort of doubling living standards every generation. Other countries didn't. They were much later starters. And what happened to incomes across countries? Huge disparity. You can just sort of, you can see this trend. This is a log scale, so straight lines, a constant growth rate. This is living standards, almost 2% growth per year, double 36 years. You can see the Great Depression and the wartime boom. The wartime boom was not in consumption, private consumption. It was in public consumption. Private consumption went down. They stopped selling automobiles. They rationed things. Okay, so what about today? This, if you put the next 9 months on it, just continue that dotted line. You can see this depression of about 10%. That has been going on for nearly 4 years. This is depressed relative to the pre-2008 trend, which had been holding for many, many years. In the 30s, we did not come back until there was a shift in the ruling policies of the ruling coalition, or a change in the ruling coalition to the and if anything, we're sinking further behind. Japan lost 10 years of their productivity growth was almost zero, and they lost 15% relative to the U.S. and Western Europe, which were growing at a healthy rate in that period. By the way, I was over in Australia and looked at this, and they didn't experience this depression, though recently they've run into problems. They had a policy regime change. But so that brings me to, I'm a central banker. This does not reflect the statements or views of the central bank. They're purely mine. Using this methodology, and a lot of people introduced, they call them frictions. I don't like that word. I like friction when I'm talking about physics. I know what it is there. But various things like staggered contracting. You can't change your prices, sticky prices they call it, except a random group can change it in the period, and there's all kinds of variants. People look using this methodology, exploring these, found they don't do it. They cannot generate, the models cannot, with these features, cannot generate observations consistent with observables. Monetary policy is important for inflation. You've heard a lot about these QE 1, 2, 3s, and factorial, where n is a big number. The tripling of the amount of assets and liabilities of the Federal Reserve System. This is just a lot of shuffling of balance sheets. It has no real consequence for output and employment. By the way, Japan has had near zero short-term interest rate for 20 years. The first 10 of those was their lost decade of growth. The next 10, they recovered a little bit, but they've been growing at slightly faster than trend. They're not growing very fast because of population growth. The working age population is shrinking. Now, one thing I want to come down to what you people do. Most of you are developing better production procedures. Does that show up as an item on the balance sheet of the firms, like a building or a vehicle or a desk? No. You're producing technological know-how, which is an asset, but it's not measured output. It is expensed. A big chunk of output is being missed. By the way, this is what accounts, this unmeasured investment had to be included to account for that big boom in the 90s. In fact, output was a lot bigger, a lot bigger than measured, an extra 4%. And that boom was bigger than, as everybody knew, what the heck, the students in the MBA programs at ASU were sort of dropping out to start their businesses in other business schools. The entrepreneurs, the people that in LA were sort of, they'd throw the $20 tip to the cab driver. They're not doing that anymore. Your activities are investments as they enhance future production possibilities. And they're an important investment. This intangible investment is as big as that intangible. But they are not counted because these investments are expensed and not capitalized. To paraphrase Albert Einstein, some things that count can't be counted. What OR and management science people are doing counts, but is not yet counted in GDP. So we have some indicators of the investments here. NSF reports business investment in R&D. Matter of fact, the national accountants plan to include this part of investment. In the late 1990s, they added one thing, software. which had started getting, they're improving over time, but they got to stick to what they can count. Good accountants count in an honest report. Well, we had to use a lot of theory and aggregate statistics that are published to estimate how big this was. And as I said, intangible capital investment in stocks are as big as tangible capital investments in stocks. It's very hard to figure out how fast your knowledge depreciates. When you develop a better process, somebody else may come along and get a still better one. And it makes your capital that you produced depreciates. By the way, there were some interesting people at Case Tech. I took Russ Akoff's course. He's one of the fathers of operation research. He was a student of scientific methodology. I've run into a few of them in my career. Bob Lucas is one, and Herb Simon is another, who influenced my thinking greatly. I remember Russ lecturing, there was no measurement without theory, and no theory without measurement. It's a back and forth and spiraling up is the way science progresses. This is what's happening in dynamic aggregate economics. You look at the young people and what they're doing, the best people at the best departments, they're all following this methodology. You look at those people in the press and who are getting attention and in the politics, they're operating as lawyers to make cases for certain things, and sometimes science is ignored. But to really have some theory, you can't have a deviation from theory until you have some theory. And now we have some theories. If you look at the stock market, we're using the same theory that we use for the business cycles and growth, and it gets the fundamental value of the one of the equilibrium relationships specifies the fundamental value of the stock market as a function of the stocks of productive capital and the nature of the tax system. But the theory works great for the UK and the US. There's huge movements in the value of the market relative corporations relative to GDP. Factors of 3 in the UK, 2.5 in the US since 1960. And you wonder, the secular movements are all changes in the tax system. These deferred compensation schemes, retirement accounts, where you can defer the receipt of the income and the payment of the taxes was a major factor. And there's also some, but the same theory is, you use it, and you got to make the same assumption. You don't nail this correlation with this assumption on the adjustment cost parameter, and this observation by making a wildly different one. Lots of people in the profession do that. They worry about nailing correlations, and we want to say what theory says. And if there's a deviation, we want to know why. And these puzzles get resolved. One of the puzzles that's been puzzling everybody is why for 35 years is why the stock market is so volatile. Asset prices move around a lot more than we can explain. We have the average numbers and secular patterns, but we don't have the fluctuations. If you could make a lot of money. So the basic theory is the extended growth model, the neoclassical growth model. I mentioned the market value of corporations, Japan's lost decade of growth. The Great Depression. Economists now have the tools to address that, and some have. And we also, a group of us, 15 other Great Depressions in the 20th century. Actually, it's only 14. There are 2 not-so-great depressions. Japan didn't quite make it to the great category in the 90s. And there's also the growth miracles. And when we looked at it, there was a problem for theory. It seemed to be that they should grow even faster than they did in these miraculous situations, unless there was more capital. Well, there was more capital, and now we found with this intangible investment, it's about 1.7 GMPs. A GMP is $15 trillion. Capital in the corporate sector, tangible, that is capitalized, 1 GMP. Inventory is another couple tenths of a GMP. So these are big numbers. Well, we find that the things that abstract from monetary factors do quite well. In the attempts to bring these features in, finds that they're not that important. Sargent and Sims found that, though they are careful not to say that too loud because that's politically incorrect. Financial crises are a symptom and not a cause of real problems. Crises do give rise to regime changes. Sometimes the change is good for the real economy, sometimes it is bad. Good. Chile in 1981, after they reformed, they had a growth miracle. Sweden and Finland had their problems in 92. Finland more than recovered. Finland's problem was that the collapse of the Soviet Union, their principal trading partner, at that time. Korea had some financial problems, crisis in 97. The U.S. had one in 80-81. And good things happened subsequently. Sometimes bad things happen. Mexico and Chile's crises were very similar. Their whole banking system went bankrupt. The price of their primary export went way down. They had big debt denoted in U.S. dollars. And the interest rate went way, way up. Oakland was in action. Japan also had a big financial crisis in 92 when they were doing very well. Then they started subsidizing inefficiency, preserving the status quo, and productivity growth suffered. I think we had some bad changes associated with the crisis that occurred in about September of 2008 in this country. Moved away from pro-productivity. We've got to have people like you making our system more productive. Now, there was a key paper, was that investment under uncertainty. What did Bob and I start out to do? Well, we started out to develop a better investment equation to be included in the macroeconometric models. You won if your equation was included in the model. And there was uncertainty, and people were not dealing with that. As I mentioned earlier, I was a more probabilist statistician and not an economist at that time. I had not seen the light. Bob was the economist. So these methods, that's where the equilibrium was, elements were really the dynamic system, not the, that's not a data, not a given. You people are getting into that too with your strategic, where the agents and actors are put into the models of these evolutionary game theory structures that have people learning and conflicting and developing. In the building of network systems, the simulations, you don't. As I had said that before. What will happen with the macroeconometric models, the Keynesian macroeconometric models, you can answer questions, what will happen if I take this action? With dynamic economic theory, that's not a well-posed question. You got to know what the rules by which policy will be followed in the future. And society has to have a technology of commitment. So as I say, we can predict what will happen. And I emphasize the given in economics are people. People are so important. We got rid of equations and introduced people. We derive what the equilibrium equations are, but they're equilibrium element, not data, not givens. And willingness and ability to substitute. We don't have anything about, we just know about theory of choice. We don't have any social welfare function. But there's not that much disagreement among people on what are good outcomes and are bad outcomes. And most of the disagreement is how certain policy arrangements will or will not achieve these. How should policy be selected? To come to the end of this discussion, people should reach a consensus as to what policy rules to follow and commit to follow them after extensive discussion and after back and forth and testing, and you've got to be pretty sure that the new rules are better. I always believe stay with if the current ones are working pretty well and we don't have good evidence, strong theoretical and empirical evidence that the alternative is better, stay with the current. I don't like experimentation. What the Fed has been doing has been a lot of experimentation. They're tripling the size of their assets and liabilities. We've never done that before. Will this lead to problems? I don't know. Maybe. Maybe not. But these grand social experiments are best admired at a distance, to quote Bob Lucas. The poor people of the former Soviet Union. Finn and I advocate rules rather than discretion. The Fed should be given a single mandate to maintain price stability, and it's been doing a pretty good job of that. So I give them a good grade on that. They can't create full employment, whatever the dual mandate that is legislated in the Humphrey Hawkins bill. Well, I think these OR tools and techniques we got to use mathematics. And the course that really set me in this direction was my senior year, Sam Carpenter, Engineering Economics. And that was much better than the other economics courses I took at Swarthmore. It was sort of fun, was building models and seeing the implications and working on that. And I guess that's why I went to Case and pursued that career. Thank you for your attention. It's a pleasure to have this opportunity.